Okay, so hopefully you've tried a few of the decimal to binary conversions, and you're watching this because maybe you want to make sure that you got the process, or you just want some extra practice or some tutorials. If you have decimal to binary conversion down, then proceed to the next lecture for Module 3. All right. So first thing I'm going to do is exactly the same thing I did with the other translations. I'm going to write down my powers of 2. 2 to the 0 is 1, 2 to the 2 is 2, 2 to the, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 3 is 4, and so on. I'm just going to double my numbers each time. 32, 64, 128, 256. All right. Just to make life easy, I'm going to write above them the positions. 0, 1, 2, 3, 4, 5, 6, 7, and 8. You know what? I'm going to add a couple spaces here to space this out, make it easier to see. So the same thing I would do if I was taking a test. I would first write down the powers of 2 so I could easily refer back and forth to them. All right. Now, I need a number. Oh, let's pick a low number to start with, something easy. So I'm going to do 35. Okay. So I want to convert 35 to binary. All right, I think back to my process, my chart that I showed you on the PowerPoint, and what's the highest power of 2 I can use for 35 without going over? Well, 32 is too small, 64 is too big. 32 is going to be my highest power. Okay, so I'm going to write out 6 blanks. 1 for 0, 1 for 1, 1 for 2, 1 for 3, 1 for 4, and 1 for 5. 0, 1, 2, 3, 4, and 5. All right. Now I'm going to take the one on the far left, and I'm going to replace it with a 1. Okay, that gives me a 32 to work with. Okay, so the next step is I got to figure out what I have left. So 35 minus 32 equals 3. So I almost had it. What's the highest power of 2 I can use for 3 without going over? Okay, well, 4 is too big, so I'm going to have to use a 2. So I need a 1 in the second position, the 2 to the 1th position. Okay, so I'm just going to copy this and paste it right here. And I'm going to go to that position, and I'm going to change it to a 1. Okay, so how much does that give me? Well, 2 to the 1 is 2. So 3 minus 2 equals 1. So the only thing I have left is a 1. So that's just going to be 2 to the 0 for that 1 right there. So change that to a 1. Okay. 1 minus 1, if you'd like me to write this down, oops, equals 0. So I'm done. I just fill the rest of the blanks with zeros. I have 3 blanks right here. So that's going to be 1, 0, 0, 0, 1, 1. If I want to represent this as a byte, then I simply put 2 more zeros right here. So I have 8 zeros and 1s. Why can I do that? Well, let's stop and think about that a second. Why can I keep adding zeros to the left? Well, it's really easy if you think about it. What's the difference? I need some more space here. What's the difference between 9 and 0, 9? Absolutely nothing, because the number on the left is a 0. It doesn't add anything to the value. And if I put the 0 on the other side, I would get 90. If I keep adding zeros, I keep going up in value. But if I go to the other side of the 9 and add zeros, it doesn't really matter. In fact, I can add zeros here all I want to. The only reason I keep adding zeros to the left of the binary numbers is to make them an even 8, which makes a byte, which is typically how we see the binary stacked. All right. Well, let's try another. How about 330, oops, that was 3,000, 321. Okay? Well, oops, I'm not sure anymore. 256 is less than 321. Oh no, what am I going to do? Well, let's just add another power of 2 here. What's 256 plus 256? That would actually be 512. Okay, 512 is too big, so we just need to use 256. Okay, that's 9 positions, 0 to 8. Gets a little confusing sometimes. You have to remember, we're starting to count at 0. So I'm going to write out 9 blanks. 2, 3, 4, 5, 6, 7, 8, and 9. Okay. If, on the far left, I replace the blank with a 1, then I've essentially used the value 256. Okay, 321 minus 256 equals 65. Oops, 65. All right, so 65. How close can I get to 65 without going over? Okay, well, let's see. 128 is too big. 64 is less than, so we're good there. Okay, so we could just use 2 to the 6th. Okay, so I'm just going to copy this down here. So let's see, this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, and 2 to the 6. Okay, 2 to the 6th is 64. So 65 minus 64 equals 1. All right, that was pretty easy. 2 to the 0 is 1. So all I have to do is change this last blank to a 1, which would mean 1 minus 1 is what I have left, which is 0. So now I just have to fill the rest of these blanks with zeros. Okay, awesome. If I want to represent it as a byte, then I just need to divide this up. Let's see, that's 8 zeros and 1s right there. Typically, we kind of divide them up into 4 as well, just to make life easy. Add 3 zeros here, because I can add as many to the left as I want. And then add another 4 here. So to represent this number, we actually need 2 bytes. Byte here, 8 zeros and 1s, and a byte here. Okay. So let's do one more. Let's see, how about 1,278? Picking numbers at random here. Okay. What's the highest power of 2 I can use without going over? Oh no, once again, I'm too small at my upper end here, so I'm going to have to figure something out. So I'm going to go over to a 10th position. 512 plus 512 is 1,024. Still too small. So I'm going to add another position. 1,024 times 2, or 1,024 plus 1,024, will be 2,048. Okay, good, and too big. So I'm going to need 11 positions, 0 to 10. So, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Change this one to a 1, which means I can use 1,024. 1,278 minus 1,024 equals 254. Okay, it's the highest power of 2 I can use for 254 without going over. Okay, back up, 256, too big. Oh, 128 then. 128 is too small, or it's between 128 and 256. So we'll use 2 to the 7th. Okay, let's copy this here so you can see the progress. So this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7th. Okay, so that gives us 128 to play with. So we'll go 254 minus 128 is going to equal 126. Okay, the highest power of 2 for 126 without going over. Well, 128 is too big. Of course, we just used that, so we know we can't use it again. 64. 2 to the 6th. Okay. Let's take this and copy it here. So this was 2 to the 7th. So that would be 2 to the 6th. 126 minus 64 equals 62. Okay, we're getting there. Let's see, 62, 64 is too big, so we're going to need a 2 to the 5. Okay. So 0, 1, 2, 3, 4, and 5. Okay, we're just kind of going down the chain here. 2 to the 5 is 32, so I'm going to need more screen here. There we go. So 62 minus 32 equals 30. Okay, so the closest 30 without going over is 16. All right, so I'm going to need a 2 to the 4. Just copy and paste that there. 0, 1, 2, 3, and 4. Put a 1 there. That's going to give me 16. 30 minus 16 equals 14. Okay. So we need a 2 to the 3. 8's as close as we can go without going over. Okay. So copy this. So 0, 1, 2, and 3. We need an 8. Put a 1 there. 14 minus 8 equals 6. All right, so we scroll back up here. So we're going to need a 4, which is 2 to the 2. 0, 1, 2. So I'll put a 1 there. So that gives us a 4. 6 minus 4 equals 2. Okay, now we need a 2. Oh, 2 to the 1 is 2, so we've finally made it. So 2 to the 1 is 2, and 2 minus 2 equals 0. So now we just need to put zeros in these extra spots. Okay. As you see, all we're doing in any of this is trying to figure out which powers of 2 we need to add together to equal the number that we're trying to translate. So 1,278 would be 0, 1, 1, 1, 1, 1, 1, 1, 0, 0, 1, 0, 0, 0, 0. If we want to write it out in bytes. Oops, missed a 0. There we go. All right, pretty easy stuff.